Greetings, everyone. Thank you for joining today. Today we're going to be covering a session on how we can use some new tools that are available in GridGain and in the upcoming Apache Ignite release to debug problems that are related to performance. So the agenda we'll be following is, for those who are new to Apache Ignite and GridGain, we'll just give a very brief overview about the framework, the use cases that it supports and how it works. And then we'll dig into why people would want to use tracing. We'll look at how tracing has been instrumented in Ignite and GridGain. And then we'll look at tooling that supports tracing and how we can look at the nodes in our clusters, collect traces and spans, and then we'll do a live demo where we have set up a scenario where we're looking at some transactions that are running across our cluster, and then look at ways that we can analyze the transactions and try and tweak them to improve their performance. And then we'll do Q&A at the end. So let's start with just an overview of what is GridGain in Apache Ignite. Apache Ignite and GridGain is our memory-centric data platform that's used to build fast, scalable, and resilient solutions. They're used to provide speed and scale to new and existing data-centric applications. And there's really kind of two flavors. There is the open source Apache Ignite project, which is developed in large part by GridGain and by our open source Apache community. And then there is GridGain, which provides some additional enterprise features on top of Ignite. So some of the things that, some of the kind of key features that people like about Apache Ignite is that it provides a distributed memory-centric storage so that we can store giant data sets in memory and add node capacity horizontally so that we can get speed and scale. We have the ability to configure co-located compute, which brings the computations of our applications and custom code to the servers where the data actually resides in order to try and reduce or eliminate network bottlenecks. There's a couple of ways that we can interact with the data that is in our caches. One is through key value, and the other is through distributed SQL. And the distributed SQL supports ACID transactions. There's a number of client technologies that are supported to access these clusters, including Java-based clients, .NET-based clients, C++, PHP, and REST. And it supports a wide variety of use cases, including banking, real-time product pricing, reconciliation, risk calculations, analytics, machine learning, those types of things. So, and on top of Ignite, we layer some additional enterprise features with GridGain. This includes monitoring tools. This includes a security and auditing framework, the ability to do in-place upgrades of your clusters with zero downtime, data center replication so that we have multiple clusters that are replicating data across different data centers, and then also some additional enhancements and enterprise features around persistence, particularly allowing this in-memory data grid to use persistence to become an in-memory database, and then also to be able to use persistence to take backups and snapshots for recovery. So that's the basics of the platform. So why would someone want to use tracing? Well, traditionally in monolithic application development, we might instrument our code to kind of debug, use logs, or use thread dumps. And because a monolithic application is generally self-contained, those types of tools are generally enough for us to be able to get to the root cause of problems. As applications have been moving to a more distributed kind of architecture using microservice architecture, or in the case of in-memory computing, spreading our applications across multiple nodes in a distributed system, it's harder to use those traditional tools like logging, debugging, and thread dumps to follow the execution of an API as it traverses the different microservices. And so what does tracing do? Well, it allows us to analyze the execution of our applications, regardless of where that execution is occurring, whether it's in a specific node or whether it's in a different microservice, and whether it jumps between the different pieces of this distributed architecture. It's useful for analyzing timings of an API call to understand how long it's taking an API to execute. And it's just adding us another tool to our root cause analysis toolbox. Now, there's a number of ways that we can instrument tracing. One of the common ways is this through an open standard, and actually there's multiple open standards, but the one that we have, that we're going to focus on today is OpenCensus. Now, OpenCensus was originally developed by Google. At the same time, there's another open standard for tracing called OpenTracing, and those two projects have now merged into a single standard called OpenTelemetry. For today's discussion, we'll just be talking about an OpenCensus-based instrumentation of tracing. So OpenCensus is a set of libraries for various languages that allow you to collect application metrics and distributed traces, and then transfer that data to the backend or monitoring tool of your choice. And the data is useful. The data can then be analyzed by developers or administrators to understand the health of your application, debug problems. Many of the popular languages, and probably the languages you're using today, have already been instrumented for OpenCensus. That list includes Java, C++, C#, Node.js, and more. And what's nice about that is that because these core languages have been instrumented already, it makes it very easy for you to turn on tracing and span collection, which is a term I'll define in a moment, for those languages, so you can immediately start getting benefit of analyzing the execution within the core of that language. OpenCensus also makes it easy to extend the instrumentation to your custom code. You don't have to rewrite your application. You just add some additional logic or annotations to your code, and then you can also collect additional spans for your custom application. Because it's an open standard, many monitoring tools support OpenCensus-based tracing through the use of exporters. And we'll look at one such tool that supports OpenCensus collection today. Now, today for this session, we're really going to focus on the tracing side of OpenCensus, but there's another side of OpenCensus as well, which is metrics. And we may cover that in a future talk, actually. So let's talk about how OpenCensus was instrumented for GridGain and Apache Ignite. So there's really two main pieces when we're thinking about traces. The trace, which is the full execution of some sort of API call that we're interested in, and then its individual components, which we call spans. A span is a unit of work. It usually includes metadata about the work that is occurring, including the time spent and maybe possible latency, the result of that step in the execution or a status, and then any additional tags or attributes that might be specific to that API call. For Ignite, that generally will include the name of the API that was called, the node where that API executed, when that API call started and when it completed, its status, whether it failed or passed or has some other status that we need to report. And then depending on the API, you may have some additional specific tags that we add. That could be things like a stack trace. It could be things like, in the case of discovery, It could be like your topology version, whether it's incremented or not. It could be any number of additional internal information about that API. And then it could also have a pointer to relevant logs in that span. So which parts of GridGain and Ignite have been instrumented so far? So there's 4 sets of APIs that have been instrumented for span collection. That includes transactions, discovery, exchange, and communication. Today we'll be focusing mostly on transactions. But once you've enabled tracing on your cluster, and you turn it on for maybe discovery and exchange, that would allow you to start to understand traces and this events around kind of like node join events or partition map exchange. But we can, we'll save those types of analysis for a future session. So specifically, how do we enable tracing in GridGain and Ignite? Well, there's a version requirement because we only instrumented or added the ability to support trace span collection as well as OpenCensus-based metrics in the latest releases. So that would include GridGain 8.7 and then the upcoming Ignite 2.9. So Ignite 2.9 isn't quite released yet. It's undergoing some final verification. But once Ignite 2.9 releases, then you'll be able to start taking immediate advantage of application tracing. So there's a few configuration steps that are needed once you have one of those supported versions. One, you need to ensure that your Ignite OpenCensus library is on the class path. Depending on the version of the runtime, it may be shipped in the optional libs directory, in which case you would want to just move it into the libs folder. And then when you restart your cluster, that will add the OpenCensus libraries onto your class path. Once it's on your class path, then you would just need to make a couple of additional changes. One is you'll need to add the tracing SPI to your configuration file, and I'll show you an example of that when we get into the demo. It's just a simple one-line property that you need to add to your, say, your Ignite config XML. And then we would need to actually call our control utility to turn on tracing. And that requires 2 arguments. One is the scope. So that would specify which API that has been instrumented in the framework we want to collect traces on or collect spans on. So that would be, in this case, for the demo today, we will turn on the scope for transactions or TX. And then we need to decide on the sampling rate. And that ranges between 0 and 1. And you can have decimals basically to describe like a percentage in between. So 0 means that we will not collect any spans. And 1 would mean that we would collect spans for every call of that specific scope. Probably wouldn't so you probably wouldn't keep your sampling rate at 1 for a very long time, because that would mean that you're collecting spans for every execution of, say, transactions or every time a discovery event occurs. What else? One nice thing about being able to control the sampling rate via our control sh script is it allows you to selectively enable and disable tracing on a running cluster without having to restart. So if you are noticing, so a lot of times people use tracing more as a forensic tool. So maybe they're noticing that something a problem was occurring, and if they're trying to reproduce it, maybe they hadn't enabled tracing at that point. They could go into control sh, enable tracing for the relevant APIs, decide on a sampling rate, and then go start to monitor the execution and start to look at spans to see kind of what are the relevant stack trace information, what are the timings, what are the logs, things like that. So we'll be focusing on a tool that supports the OpenCensus instrumentation of tracing and also metrics. which is our tool called GridGain Control Center. So GridGain Control Center is a monitoring and management development tool for Ignite and GridGain. Supports the latest releases, and it's basically a visual kind of UI tool. Let me just do a quick overview of some of the key features. Particularly, we'll talk about the ones that are relevant to OpenCensus, and then we'll get into a demo. So one of the key feature areas that are provided by the tool Control Center is the ability to collect spans from an OpenCensus based system. So this is set up out of the box for GridGain and once Ignite 2.9 releases. You need to, as I was mentioning before, set up your tracing SPI in your configuration file. But once you do that and decide on your sampling rate, turn it on, then we'll start collecting those spans. And so what are the spans doing? So it's allowing us to take an API, break it down into its requisite into its component execution events, analyze the timing, look at some additional details about those calls, and then try and give us an easier way to debug. This is pulling information across multiple nodes in your cluster. So it's a very different way of debugging compared to how you might have done it traditionally with Ignite. You probably, if you've had to debug issues in the past, you would have to pull logs or thread dumps from multiple nodes in your cluster, look at timestamps or labels, and then match them up to try and understand when execution is in one node and when it jumped to the other node. Maybe pull additional logs from additional nodes, and then just kind of jump back and forth between log files. While enabling tracing, Control Center, and actually, to be perfectly honest, other tracing tools can also do this as well. But they will collect that information and give you a single UI that will combine all of that information so that you have just one place to analyze execution across multiple nodes. The other side of OpenCensus is around metrics. And starting in GridGain 8.1 and starting in Ignite 2.8, the metrics framework has been redesigned to be OpenCensus compliant. What that means is that with custom exporters, you can very easily monitor the metrics in your clusters in any tool that supports OpenCensus. So Control Center has OpenCensus exporters configured out of the box. So the moment you connect to a GridGain 8.7 or Ignite 2.8 cluster, we'll start collecting metrics and showing them. As part of this kind of redesign of our metrics framework, you now have access to over 200 metrics that you can analyze and build alerts around, as well as just monitor in either Control Center or any other tool that you might be using that supports OpenCensus. So alerts is a new set of features within the Control Center that allows us to build custom alerts for any metric. We just select the metric, define some conditions, and basically decide on our notification channels, which it could be email or SMS or UI based, and then let it go to town. And then it will start monitoring and the connected cluster or clusters, and let us know if any of those conditions have been violated. There's also some additional tools that aren't related to OpenCensus within Control Center. One is around querying. So if one of the most popular interfaces into the data in Ignite and GridGain is through SQL. So we provide a SQL IDE integrated into the tool that allows you to run SQL statements, introspect into their execution by analyzing their explain plans. We'll give you some tools to help you analyze running queries, as well as collect statistics on queries that help you try and fine-tune your query execution. And we'll show you just a very short demo of that. Another part in Control Center that is can be useful when working with Ignite clusters is visualizations or more information about rebalance events. So if you're using Affinity to spread your data across multiple nodes, multiple copies of your data across the nodes of your cluster, if you change baseline topology, or if you were to add and remove nodes from your cluster, sometimes that might trigger a rebalance event where the data on your nodes will then be copied spread across the nodes in order to try and prevent any possible risk of data loss. As that rebalance or partition map exchange is occurring, it can be maybe not a little bit opaque as to how the progress is occurring, which nodes are being rebalanced, things like that. And so our tool provides some new visualizations to help you understand exactly when rebalance occurs, which node has been rebalanced. If a node for some reason got stuck, it'll give you a very easy way to jump into those details and debug. Also, if you're using one of the enterprise features, the more enterprise editions of the GridGain framework, such as Enterprise Edition, this also helps it with rolling upgrades in order to help you understand which nodes have been upgraded to a new version, which ones haven't, and then give you some indication of status. Also, if you're using the more enterprise versions of GridGain, such as GridGain Ultimate Edition, we provide some tools around backup and recovery in order to take snapshots. So you can take your cluster, back up your data, check it, analyze it, move it, and then if for some reason there was a problem, either there was an instability in your cluster, or maybe some data was pushed out into the cluster that was corrupted, we can always just roll back. And that's through the snapshots utilities. So this is giving you a graphical way of working with and taking snapshots. So how do we get started with this demo? So in order to enable monitoring on this cluster, we need to activate our agent. So if we're working on the GridGain side, GridGain ships with our control center agent in the optional libs folder. We just need to copy the agent into the libs and then just restart the cluster. And if we're on the Ignite side, we need to grab that agent either from the GridGain or the GridGain Maven repository, or download it from gridgain.com and drop it into our Ignite libs directory. Once we start the cluster, you'll be presented with a token ID, which is used to authenticate the cluster to the monitoring tool, and then you're good to go. So let's take a look at a demo and start to kind of understand how we can use tracing on a transaction-based or a cluster with a client that's running some simple transactions. So I'm going to be doing everything locally. I have a local version of GridGain Community Edition. Unfortunately, I didn't because I wasn't able to grab a development edition of Ignite 2.9. So I am going to be using GridGain Community Edition for this demo. And then I have a local control center running on my system. We also have a hosted version of Control Center if you don't want to run it locally. And so this is going to be a 2-node cluster where one node is a server node and the second node is a fit client that is actually running the transaction operation. So let me switch over and show some configuration just so we can review how we enable tracing in our configuration. So this is my Ignite config XML. I've enabled a few different properties. I've enabled persistence, I've enabled discovery, but the important thing for tracing is the tracing SPI. So that is here. So I've got a property called tracing SPI that's going to add the OpenCensus tracing SPI class to our configuration. So I have a server node. It's just starting up a basic node, and that is running here. I launched it through Maven, and it looks like it's still up and running. And then I have a transaction, and the transaction is here, and we'll let it run for a little bit and then we'll debug and get into some of the execution details. But we can see here that the transaction is running. It's given. I have a little print line that's saying, basically alerting me when a transaction has been committed. So now let's switch over to our tool and analyze the execution. So I'm running GridGain Control Center locally. I have my cluster running, so I can see that it's active. I can see I've got my client node, and then I'm running Community Edition 873, and I have a very simple baseline topology. And so let's first just give a quick overview of some of the other things that we're seeing in this UI. So on the left are my tools. So I have the ability to analyze metrics, and that's what we call a dashboard. So the dashboard is basically reading the OpenCensus based metrics from my cluster and pulling individual metrics in, basically visualizing them into different widgets. So what I'm seeing here is the list of my nodes. So I've got two nodes, my coordinator node, which is my server node, and my client node. And then we provide some additional details about those nodes. And I can even expand the list of details, such as consistent ID, the order, the MAC address, things like that. And then I have a few different basic metrics that I'm pulling. So for example, I'm showing my CPU load, which is currently pretty lightweight. I've got my heap size that I can see here. Because we're running some kind of variable transactions, I see that it's adding and removing, it's changing my heap usage. And then I can get to the details in a table of my heap if I want to select or add additional metrics. I can do that very easily. Maybe I want to see a comparison between heap and off heap usage. So I can very easily just add that here. And then I also have a heat map. And so heat map is another visualization where I can select an individual metric and kind of show the metric consumption or usage or thresholds across all of the nodes in my cluster. So in this case, I've set the CPU load. If it's anywhere from 80 to 100%, then I'll show different colors. But I can switch that to other metrics as well. So if I wanted to maybe show heap usage, similar to the graph that we have there, I can set that. Maybe change my threshold to something that's a little more realistic than a single byte. And then we can see, as the heap increases, then if we've set some different thresholds, set some alerts, then we can see it visualized very easily on the heat map. Similarly, I've created some additional diagrams or some additional dashboards. Some are specific around transactions. So I can see here that I can see the user time for this transaction. I can see how much time we're spending executing the different components of my transaction in my client node, plotted in a histogram. And then I've also created some additional transaction details, including the number of transactions, the size, some timing, things like that. If I wanted to add additional widgets, I can do that as well, just by dragging and dropping widgets into my UI here. So maybe I want to follow, say, for example, my rebalance. I'm not adding or removing nodes, so I don't expect any rebalance events to happen, but it just makes it easy to just kind of continue to add additional metrics. For example, if I wanted to have some specific charts around threading, I can do that as well. I've also set up some alerts. So these are pulling from the same set of open metrics, OpenCensus metrics. This one is saying, if the CPU load gets higher than a specific value, then hit off a notification, which I can see here. The CPU load is very low, so it hasn't exceeded like 15%, so I'm okay. But I could very easily add additional alerts. But let's get into tracing. So what am I seeing here? So in my tracing UI, I see I am collecting different tracing events. These events are, I can see the time, I can see how long they took to occur, and I can see the total number of spans that are within those traces. And I notice here that as I'm scrolling through these traces, kind of the average time went from 10 seconds up to a minute. And so let's maybe take a look and see what's going on here. So let's pick one of these existing transactions and look at the span details. So when I select that transaction, or sorry, when I select that trace, I can get into the details of that trace. So I see that it's taking this duration. It has 22 total spans with this depth, and this is the date that it occurred. So this transaction initiated on my client node, which is this 220F. And then let's kind of talk about what's happening here. So first we do a read on our cache. And so we read the data. Looks like we performed a write operation. If we want to get into any of the details of this, we can expand. And so this was the events that happened during that read. If I select any of the individual spans, I can get into the details, such as the nodes that were involved and whether the execution succeeded, which we see it does. We're seeing here that the execution is actually going between our server node and our client node. So we went back to the server node, back to the client node, and then here's where we did our first write. So this is where we wrote some data to the cache. We can get some information here. And we see here that the timing is just happening really quickly, right? So these events are taking like 0 milliseconds, 1 millisecond, 0, 0, 0. They're all happening right at the right when the transaction initializes. And then we do a second read, or sorry, a second write. And that write happens quite a bit later. It happens actually at the end, almost at the end of this transaction. So there's something going on between the first write to the cache and the second write to the cache. And then everything else just proceeds normally again, really quickly. So let's go into the code and see what happened there. So let's switch back to my IntelliJ idea. So let's go back into this transaction. So we created our transaction, we did our read, and then we do our writes. And so here we did our first write, and then we had a sleep. And then we do another write, and then we do our transaction commit. So it's this spot here in between these two in between these two cache events is where we have the sleep, and that's probably the problem. So what if we were just to reduce this down a little bit? So let's save. Let's do rebuild. And let's do a restart. So now we see things are going much faster. So it seems like that is the problem. It's this events that are occurring between these two cache events are where we're noticing we got these issues. And so now when I go back to my tracing view, I can see I'm getting a bunch of new traces. So let's refresh. Okay, so now we see our transaction occurring in about a second, which makes sense because we reduced the sleep. So let's now take a look at the details. Right, so now what we're seeing here is that, right, we're having our set of write event, we have our lock, and then we do the write again, but it's happening much quicker because we reduced our sleep time. So what is this showing us? It's showing us that when we have a trace, we can break down that trace into its, kind of its component spans. And with those spans, we can get information about what's happening. We know where the execution is occurring, on which node, or whether it's in a server node or a client node. We can get information about timing. We can get information about whether the individual call of that span succeeded. And then because we're able to collect these spans across multiple nodes, we can watch the execution regardless of which node this is occurring. So we see even here that it's jumping between multiple nodes. We didn't have to go into individual nodes and pull individual logs and match up timestamps. All of that is stitched together for us by the tool. So there's some additional features that we have within Control Center. One more I'll just mention is the ability to work with SQL. So I have, in this case, I didn't really put too much information into this server node. So let's just see here. I have a very simple cache that's got a person. It has a simple table here. I can see the columns in that table. If I wanted to maybe run a very basic query, I can do that. So this is all aware of SQL syntax. And I can get content assist for the language of SQL, as well as from the connected artifacts in the cluster, in the schema. So I can very quickly just say, go in here, say execute, so I can get the list of people that returned. I have some advanced options, so I can do things like, lazy loading, or execute the query on a specific node. That would give me some indication of how my data is spread across the nodes of my cluster. I can do other advanced options as well. If it's a long-running query, we give you some details about, and so that you can analyze the query to see kind of what's happening and why it's running for a long time. And then we can also get details about query statistics. So we can see which queries have been executed, how long they took to execute, their failure and success rate, and then even get into the explain plan so that we can look at the internal implementation and execution of SQL within like Ignite or GridGain. So going back to slides, so that was the basics of kind of how we enable tracing in our clusters. So remember, it's a few steps. We need to make sure that the tracing is available in our class path. We add the tracing SPI to our configuration file, and then we turn on tracing by calling the control sh utility, deciding which APIs we want to collect details on, and the sampling rate, and then that will start to produce those spans. And then any OpenCensus compliant tool can collect those spans as long as we have an exporter available for those. So Control Center is configured out of the box for this. It makes it really easy to analyze both the OpenCensus metrics and the traces. So if you're interested in more information, we have a few different versions of Control Center. One is a SaaS version that's available online. You can set up an account for free, connect your clusters. It has limited functionality only in that we don't expose all of the administrative functionality in that version. But everything I showed today, including tracing, metrics, SQL, are available. And then we have two downloadable versions. We have the free developer version that you can download either as a zip or as Docker images. And that has a node limitation. And then we have our commercial edition, which is more for production monitoring on premise. And that is priced by, that uses a per node pricing. And you have full control over those, these downloadable versions. So let's open this up for questions.
All right. Awesome. Thanks, Greg. I'm just gonna post a link to Control Setter in the chat window as well. Audience, if you have any questions for Greg, please enter them in the question section in the GoToWebinar control panel. All right, so we had a couple of questions in already. The first question was came in early in the presentation, Greg, maybe on slide 2. They were asking about how does Apache Spark fit in the overall architecture here?
Actually, we have a whole webinar that talks about Spark integration. So there's that Spark is let me just pull up the documentation here. Let me get the link. But yeah, Spark is supported. We have basically plugins for Spark for Ignite. So you can add Spark in as a like a data source. So let me just see here, Apache Spark and Ignite. See if I can find it right now. But there, we have had sessions in the past that describe this.
All right. There's another question that came in. This is more, a high-level question from a new user to Ignite. They're asking how should they think about Ignite versus other, products out there like Redis or Memcache as an in-memory computing platform. Do you want to comment on that?
Sure. So yeah, so Apache Ignite's giving us the ability to do to load massive amounts of data in memory, and because it's a distributed system, we continue to add nodes to be able to scale to support as much data as we need. We're basically limited by the physical resources that our infrastructure holds. One thing about Ignite that and GridGain that a lot of people like is that people coming from any kind of relational database background are very comfortable with SQL, and Ignite and GridGain are fully SQL compliant, including the ability to run SQL queries, and those queries will run distributed across the data set, across your nodes. So it's a much more kind of natural way for people that are coming from a relational database background to work with their data in memory. There's a lot of other benefits as well, and I can provide some links after the session. Actually, I have some at the very end on this last slide.
So that's great. And then one other question is, how does the tracing capability, is there any difference in tracing capability between the different versions, between Ignite and Community Edition?
Actually, there aren't. So it's essentially the same. So the innovation for tracing occurred largely on the GridGain side, and this has been contributed into Ignite. So the only thing that you would need is to just get one of the versions of Ignite that have tracing enabled. So that will be starting with Ignite 2.9. So Ignite 2.9 is not quite released yet. They're just wrapping up that release. It should come out soon. And once that's released, I highly recommend that you check it out. Add the tracing library to your class path, start collecting some spans, and see how it works for you. But otherwise it's the same.
All right. So here's a question. So given that we find out about bottlenecks via tracing, how can we know which areas we should work on to improve performance, like tuning versus network latency versus I/O latency? So I guess how do you go about getting started?
So where tracing will help you with respect to Ignite and GridGain is it will let you know if there are bottlenecks like in your code that's executing across the clusters. So you can instrument your own code, and then you can also you would also collect spans as your APIs execute say in transactions or discovery, or other things like that. So this is helping you kind of debug issues that are inherent in the application that you developed. There are other tools that you can use that will analyze, say, network latency or storage or things like that. But this is really to help you find out if the problems that you may be experiencing related to performance or just debugging are in your code itself. And it's making it easier to get to the root cause by giving you a hint as to where you should start looking.
All right. And then maybe a quick one, like, can tracing be visualized with Web Console?
No, so yeah, that's a major difference, is that as part of this kind of overhaul of Ignite and GridGain to support OpenCensus, you need an OpenCensus compliant tool in order to collect traces and as well as view these new, like the new style of metrics. So unfortunately, Web Console is not OpenCensus compliant, so it doesn't support tracing. So if you wanted to take advantage of tracing using our tools, you would want to look at GridGain Control Center.
What kind of performance impact does this have? And is this really mainly for development environments, really?
No, it can be used in production as well. So from our benchmarking, a lot of it depends on your sample rate and what kind of percentage of the execution calls you're collecting spans for. But we've seen, at least through internal testing, it may add up to about 5% overhead to the execution of your environment. It is useful both in production as well, and because you can selectively turn on span collection without having to restart the cluster just by calling into like the control sh utility, it's actually kind of well positioned to do to debug issues in production, because you can turn it on, collect some spans, analyze the spans, and then just turn it off without having to like take down your production environment.
That's great. What are the typical things that you need to check in the logs to find out, what may be causing latency? Just as you were showing in your demo, right, with the sleep. Is there anything else you typically want to look at?
So I would say that just by analyzing kind of the execution of the individual API calls, it gives you an idea of where kind of a slow operation may be occurring. So it could be something like, oh, maybe you're making a call to a resource like too often, and you need to change how you're calling that resource. Or in this case, there was essentially like an operation that was, pausing. But I would say that by looking at the span data, it can give you a hint as to how long different events are taking to execute or when they're starting. And then just by traversing through those individual spans, that should give you an idea of where in the code you should start your investigation. So I don't know if that exactly answers your question. But the things we have instrumented today with GridGain are around data exchange. So that is when if you're using like Affinity or to put copies of your data across the nodes of your cluster, we can enable tracing there to debug those issues. Node join events. So if a node is joining or for some reason it crashes and drops from the cluster, we can enable tracing around those events and analyze those. And then the one I showed today was around transactions. So there are other APIs within Ignite and GridGain that we're in the process of instrumenting. So not every API within the product is fully instrumented yet, but it's something that we're basically adding additional instrumentation with each release.
Cool. That brings us to the end of this webinar. I'll be sending a follow-up email later today with a link to the recording and the slides. Awesome. Thanks, everyone. Thanks, Greg.
Cool. Thanks, everyone. I appreciate your attendance.